Hello everyone. What we're going to do today is a quick walkthrough of how permissioning works on a Besu blockchain network. And we'll be using one of the examples in our sample networks repo. To start things off, I'll just share my screen and we'll talk about the different kinds of permissioning first, and then we'll get stuck into it. Okay, so at the heart of it, there are two different kinds of permissioning that you can use. So the first is local or off-chain permissioning, which is where you can restrict the use of resources on your node, or basically what's under your control. So for example, which customers have access to your node, or what accounts can be used to make transactions from just your node. But these accounts are free to make transactions from any other node on the network if they're allowed to do so. The second kind is the on-chain permissioning, which essentially deploys a contract to the network, and rules for nodes and accounts are specified in those contracts. And any node that connects to the network abides by these rules. What this means is if you need to make an update, it's not just to your specific node, but to every node on the network automatically gets these updates. So we'll start by doing a quick overview of what we've set up today. I've set everything up just to save time by using a script called run-permissioning.shell. This sets up a blockchain network for us using Docker Compose. Essentially, this consists of an IBFT network with 4 validators, the boot node and these 3 validators, an RPC node, which is used for communication, and 2 extra nodes, which we'll be using later on to demo how permissioning works. In addition to this, we've got a standard monitoring set up with Prometheus and a custom Grafana dashboard, which enables us to check on the blockchain, make sure everything's humming along perfectly fine. And the last thing that we'll be talking about is the Dapp, and then we'll be demoing how to use the Dapp as well. All right, so before we get started in there, to spin up the network first, we need to add a couple of things to the Genesis file itself. And these two are the node and account ingress contracts. Ingress contracts are basically proxy contracts that are defined in the Genesis file, which act like pointers to node and account rules via contracts. And that's why these addresses are static. So these 8888 and 9999, that's where these numbers come from. You can use any values that you want over here, really makes no difference. Because this is the start of the network and nothing's on there, it just guarantees that for the life of the network, these addresses will not get used, and any updates that you make to the contracts themselves will be handled as transactions, so you're perfectly safe. Okay, so the way we've got the values for the code is we have specified some contracts. And the contracts that we've used today are found in the permissioning smart contracts repo. So I've gone and checked that out down there. I've compiled the contracts, and what I've got is a set of deployed JSON artifacts, which are found here. So there's an account ingress and a node ingress further down there. And the value that we're looking at is the deployed bytecode. So that's where the 0x608 comes from. There we go, for that one. And same for the node ingress contract. The storage values, the 0, 1, and 4, are effectively the defines the rules and the contract addresses, as well as the ingress contract version for each of these respective contracts. All right, so now that we've talked about how we've got there, let's make sure our network is up and running. And it looks like it's humming along nicely. Yeah, we've got all our nodes in place there. What I've also done is I've set up MetaMask, and I will jump to local network. And you'll see I've got a bunch of accounts over here. So account 1, 2, and 3. Which I've got the private addresses from our README file specified here. These are 3 test account addresses, private keys. So the next thing is now we're going to start looking at the more interesting sections of it. The one key thing to note is that although I've defined these rules and things, the addresses in the Genesis file, I haven't actually enabled permissioning on this network. And the reason for that is because we actually need to deploy the contracts to the network before we turn on permissioning. And if we turn permissioning on right from the start, we kind of wind up with a chicken and egg problem. So what we are going to do now is I'm going to run this script, which will deploy the contracts and then deploy the Dapp. And I'll walk through how this works while it's running. Okay. Right. So while that's going on in the background, so essentially, again, this is from the same permissioning smart contracts code. The node ingress contract address and the account ingress contract address are the ones we specified in the Genesis file, 8888 and 9999. The Besu node perm account and the perm key are the account address and private key of the account that's deploying these contracts. In this case, that is the second address on the list for account 2. And the endpoint is, of course, the RPC endpoint over there. Now, what I've also gone and done is I've done an initial whitelist of accounts, and I've only done 2 of the 3. And the reason for that is so that I can demonstrate what happens when you try and send a transaction from an account that's not whitelisted. And I've also gone and whitelisted every single node on a network. Essentially, this is just a list of eNodes, so eNode, public address, and IP for every single node on the network, just a big list. And then we've migrated all our contracts. And the last thing that we've done is we've built a Dapp, and we connect that Dapp to our network. And once that's finished, what we'll do is we will stop the network, we will enable permissioning, and then restart the network. So what you should see is that the nodes come back up, and when they do come up, they will all have the permissioning rules enabled. So we'll just give that a few moments to take effect. And I'll quickly talk about why I've done this over here. Now, as always, you can start off with just a few nodes in there and whitelist them and then just make calls and add the other nodes in. The easier approach is to whitelist every node that you have on the network, and then as well as accounts for that matter. And then based on what you need, you can just take the nodes as well as the accounts off later on. It's much easier doing that than the other way around. The other thing is when a new node will join the network, what happens is it connects to the boot node, and until it synchronizes to the chain head, it will ignore any rules, any permission rules per se. And once it's in sync, it will then take into account all these permission node rules, make sure they're applied, and then start acting like a normal permission node. And just like the other case, if the synchronized node loses any of its peer connections or all of its peer connections, it will again connect back to the boot node and rediscover its peers and so on and so forth. So it's very important that the boot node is one of the whitelisted nodes in the permissioning setup that you have. Okay, so how far have we got? So we've stopped the network, started it up. Now we just got to wait a few more seconds for the network to come up completely. And our Dapp should also be up now. May not be functional because the network is not up yet. So we'll just give it a few more seconds. Okay, almost there. Okay. So now that we've got our nodes up, I'll just give them a few more seconds to get up to chain height. Make sure they've all connected to the peers that they're meant to be doing. Just refresh the page. Okay, so we're just waiting for some blocks to start getting created over here, and that tells us that the network is back up and running as expected. Okay, it looks like we've got some blocks being created. That's good. So we'll slowly start seeing these peer counts grow. Yep, blocks are being created, so that looks like it's all coming together well. So I'll just connect back to MetaMask. Okay, and our permissioning should start taking into effect. Okay, there we go. Right, okay, so what we've got here is we've got our two whitelisted accounts as before, and we've got our whitelisted nodes. Now, what will happen is, I'll just wait for this to keep progressing a bit more. Yep, everything's up and running fine. Okay, so what I'll do is I will take node 2 out of the equation. So this gets handled as a transaction. Let's bring that in here. As soon as that gets confirmed, that's removed. And what I should now see is that rule has in fact taken place, and it's every node on this network has accepted that. And node 2 over here will suddenly lose all its peers. And if we just give this a little more time, this will not be progressing anymore with the chain height. So that's a really quick way of showing you just how effective it is to disallow a node on the network using on-chain permissioning. Now, the second thing that we can also do is we can use MetaMask directly. So I have whitelisted accounts 2 and 3, I believe, FE3627, and sorry, accounts 1 and 2. Okay, so what I'll do is I will send some ETH between accounts, and because these two accounts are allowed to transact, I should have no problems with this transaction. And there we go, it's confirmed. And I've got a little pop-up over there saying it's confirmed. However, if I was to go and try and do that with account 3, which is not in our list, so F17, not in our list of whitelisted accounts, and try and send some ETH to, let's say, account 1, for example, and set 1 ETH. This should stay in a pending state for a good long time and never actually complete. Yep, and that'll just sit there for a while. Now, if I go back to Grafana, we should see that all the other nodes have progressed and node 2 is still stuck at 241. So that's pretty much how permissioning works in a nutshell. One thing I will add is if you are looking at permissioning in a production type of environment, setting up permission doesn't guarantee that your node is going to be perfectly safe. For example, it won't protect you against DDoS attacks. So what you need to do is also make sure that you've got proper firewall rules in place, proper security group rules in place. Use the best approach for security, and this will guarantee a few things, but it doesn't take care of everything. So you also need to make sure that you're following best practices. As always, if you have any questions, feel free to reach out. We're more than happy to help. Thank you. Have a good day.